everyone, and welcome to this talk. We are going to talk about how data engineers and data scientists can get started with Azure Synapse Analytics, Azure Data Factory, and Azure ML. My name is Nellie Gustafsson. I'm a senior program manager in the Azure Synapse Analytics team. And with me, I have Hyong.
Hey, hi everyone. First of all, we are really excited to have you join us in this session where we talk about lots of things, right? Azure Synapse Analytics, Data Factory, and Azure Machine Learning. I'm the group manager, right, for the Azure Data Factory team, and hopefully through this 70 minutes of presentation, right, we can get you up to speed on what's exciting and what's new coming up in all the services.
All right, so what we're going to cover today is, a little bit of everything, I would say. Our agenda contains, we're going to do a quick introduction and then jump into some of the capabilities in Azure around data integration and AI in Azure. And we'll show you some demos, and then we'll jump over to see how data integration and AI can come together in a platform like Azure Synapse Analytics, where we give you, an overview and kind of dive into some of the things that you need to know around ML capabilities. So the theme of our talk is basically, ML capabilities when it comes to ADF, obviously Azure ML, and of course Azure Synapse Analytics and how that brings them together. So with that, Hyong, take it away.
Sure. So I think before we get started, we would just, get a sense of what is your role, right? Whether you're a data professional or whether you're an ML professional, hopefully this talk would cover that whole spectrum of capabilities in Azure that will allow you to not only be productive, right, but derive tremendous kind of value within your organization. And more importantly, we hope that, through this presentation, right, by getting a glimpse of all of this, we'll be able to show you how you can bring it together and be able to do all this work, whether it's data engineering, feature engineering, all the way to building machine learning models, to being able to leverage this and bring a lot of this kind of prediction or capabilities, if you will, right, closer to your data. And so without further ado, we're going to start off with Azure Data Factory. Now, Azure Data Factory has gone through a tremendous journey over the past few years. And one of our goals there is really to be able to enable you to do enterprise data integration, but also making it simple for you to get started. But more importantly, be able to scale to the demands of your organization and be able to do it really easily. And so this really falls into 4 tenets. One is we have always been looking at ways of how to make things simpler and much more easy to use, right? And this includes, for example, some of the work that we've been doing with the mapping data flow, where it is code-free, right? And you could either be doing an ETL or ELT kind of pattern, right? And underneath the hood will take care of the infrastructure for you to be able to run this in a serverless manner. Now, the other piece, which is also close to my heart since I used to be part of the SSIS team, is that if you have lots of SSIS packages, and you just want to be able to run them, but at the same time be able to then modernize it, right, using some of these cloud native patterns, right? We want to make sure that SSIS packages would just run as it is in Azure Data Factory. And of course, the last part about making it easy is really the fact that, as you start building your data pipelines, as you start running some of this transformation, if you will, at scale on Azure, the other thing that usually comes to mind is how do I go about deploying it, right? And usually some folks would refer to this as data ops, but it's really the fact that, well, you have created a dev data factory. How do you leverage the deployment of this data factory under source control using a CI/CD mechanism, if you will, right? And then the other piece that we are always really focus on is how can it be cost effective, right? How can you pay as you go, as you are able to run all this data flow at scale on a serverless and fully managed infrastructure? But more importantly, as the demands of your data flow grows over time, whether it's in the volume of data that you have to process, or whether it is with the complexity of the transformation that you need to do, or the richness of transformation that you need to do. We hope that we are able to scale it for you on demand without worrying about setting up Spark clusters and so on and so forth. Right, and of course, the third pillar is really about it being really a powerful data integration tool, which enable you to connect to all kinds of enterprise data sources, whether it's on premises in the cloud, whether it's within the Azure cloud, or whether it's within some of the SaaS providers, if you will, and be able to bring this in and be able to cook the data, if you will, in order to be able to get it from raw data to insights really quickly. And of course, the key to all of this is a really powerful and rich set of orchestration capability that not only can you orchestrate at scale, but you can then monitor all this data pipeline that's executing. Right. And the last piece is also an area that's close to my heart as well, is this whole notion that, well, if we want to be able to enable you to do data integration at scale, how do we make sure that this infrastructure that is fully managed, if you will, right, is able to anticipate some of the peak workloads, right, that might happen, and so that we will be able to spin up the infrastructure before you need it. But at the same time, when you are going to run your data flow or to do your data movement jobs, right, it is ready to go. And so we've been spending a lot of time, and this is going to be a continuous journey on how can we make enterprise data integration intelligent, both from an infrastructure perspective, but as you will see later on in some of the demos, right? How can you also incorporate some of these machine learning pipelines that you might have built using Azure Machine Learning as part of your pipelines? And so today, for example, Azure Data Factory really allows you to connect to a rich set of connectors. And what I showed here on the screen is just a subset of it. And as we talked about it earlier, right, the point is to enable you to bring all this data, but not only bring all this data to a place, right, but also allow you to then be able to do transformation on it, or from a data engineer or a machine learning data scientist perspective, being able to do feature engineering on it. But more importantly, be able to bring this from raw data, cook it along the way, and getting to a point where you can deliver insights using a platform like Power BI. Now, we talk a lot about code-free transformation, which is the ability that you see here on the screen, or being able to then define a mapping data flow, right? But more importantly, this data flow will then run at scale on an Apache Spark cluster, right? But at the same time, if you choose to write code, right, if you choose to run Python code or any kinds of code in a notebook or as a jar file, we will orchestrate it for you as well, right? Now, so without further ado, let me just quickly show you what Azure Data Factory is, just to give you a glimpse of the kind of enterprise data integration capability that's available. So right now, what you see here is I've just deployed just a moment ago a data factory in Azure. And so when I go to this resource, you'll see that we have provisioned a data factory. And of course, in this case, being a Nellie and Hyong presentation, we call it Nellie factory. And the first thing you'll notice here is a very familiar experience, right, in managing a lot of the Azure resources that you might already have been working with. And to kick off the data factory experience, what you need to do is to click Author and Monitor. And what this does is it brings up the Azure Data Factory environment, which then allows you to do it in a code-free manner to define how are you going to bring the data, what are you going to do with the data, whether it's the transformation that you need to do, or whether you are going to pass it along and invoke a machine learning pipeline, right? And so right now we're loading Data Factory. And once you're in this Data Factory environment, to get started, if you're new to Data Factory, you could say, well, let's create a pipeline from template. And here we provide you with a rich set of templates that will help guide you in your Data Factory journey. So for example, for many of us who have been doing data warehousing for a long time, you could say, well, let me look for a pattern that leverages a type 2 SCD, right? Or slowly changing dimension. And so if I click on this, what you will need to do here is you have to specify a data source. So in this case, of course, you could specify a data source that is available, and you specify a SQL server. And once you're done with it and you click use this template, of course, we're not going to do it in this demo. Boom, you'll get the full thing all set up for you, right? Now let us go into creation of a pipeline. And so when I knew a pipeline, you'll see that it provides you with a rich set of activities, right? From being able to copy data. And of course, here you could say, where do you want to copy it from? And so we could say, well, let's start a new data source. And here is when you get to experience a rich set of connectors that's available in Data Factory. And of course, you could say, well, maybe I want to copy it from ADL Gen 2. And of course, you continue with the experience, right? You could say, well, it's a CSV file. And then it's going to ask you, hey, how are you going to connect to it, right? How are you going to authenticate against it? And so, of course, I will create, say, a link service. I'll select the subscription. And then this will show you all the accounts that's available here. So let me just look for Nellie account. And once this is done and I click create, you have just defined how you're going to connect to the data source. And then, of course, you go on to configure your sink. And you could say, well, this is a new data set. Again, I might want to write back to it, say Azure Synapse SQL pool. Or I could say, well, I just want to connect to ADL Gen 2. You could reuse the same link service that you have created earlier. And once done, boom, you're ready to go, right? You're ready to leverage the Data Factory data movement infrastructure, if you will, to bring data from different sources, right, into Azure. And of course, you see a lot of other things that we connect with Data Explorer. We allow you to define iteration and conditional construct, right? Where you might want to loop over a set of files, or you want to loop over a set of tables, if you will, and do something useful with it, right? And of course, you could do many, many more things with it, right? For each, you can connect this all together. And so this is essentially a data pipeline. And at the same time, you might want to also create a data flow. And so if I were to do a new mapping data flow, it will start guiding you through the creation of it. And so I could say, I want to add a source. And of course, I could say, let me specify a source. It could be a data set that I had just created earlier. Right. And once done, I could continue to say, well, maybe I want to be able to do a derived column. Maybe I want to join it with some other data, or I might want to pivot against it. Or if you're dealing with, say, JSON data, sometimes you might want to flatten it, if you will, and so on and so forth, right? And then finally, of course, you could say, well, I really want to write all this data to a sink. And this becomes, a data store that you might want to write to. Now, when all this is done and you publish your pipeline, this will then enable you to run this transformation here at scale on an Apache Spark cluster. Now, with that, I think I've given you a really quick introduction of Data Factory. Before I jump back into the slides, you'll see you could also have a good monitoring experience. And at the same time, you could also be managing different kind of settings in the Data Factory. Now, let's quickly switch gear now and talk about Azure Machine Learning. Today, Azure Machine Learning is really an enterprise-grade machine learning service that not only allows you to build and deploy your model faster, but it allows you to manage the entire life cycle of your models. And the goal there is really, whether you are a beginning data scientist or whether you're a very seasoned, experienced data scientist, we hope that Azure Machine Learning and the AI platform will enable you, right, to do ML on Azure. But more importantly, of course, it provides you with full lifecycle management. And as many of you might have been looking at the Microsoft website, etc., we have been spending a lot of time thinking about what does it mean to do responsible ML. And at the same time, also provided you with Python libraries that will actually enable you to build some of these responsible ML practices, if you will, right, into your data science process. And I think the last piece is really key, right? The goal of Azure Machine Learning is really to be open and interoperable, right? So whether you're using any of these open source Python libraries, whether it's TensorFlow, PyTorch, etc., you will be able to run it on Azure Machine Learning, right? And so without further ado, let me quickly show you a demo of Azure Machine Learning on how all of us can get started with building ML models on Azure. Now to do this, I'm going to switch to my Azure Machine Learning workspace, if you will. So let me navigate to my resource group. And now in this resource group, of course, you see a whole bunch of resources that were created for this demo. Now, the specific resource that I'm interested in here is really machine learning or Azure Machine Learning. And let me click on the Nellie Machine Learning workspace. So let me launch Studio. Now that I've launched the Studio, this is really the place where you do all your machine learning work. And so suppose now I have data, which we're going to use throughout this demo, which is retail data. I might want to build a model on top of it, or I might want to build a regression model on top of it on data that is sitting in my storage. Now, how do I quickly get started? Now, one quick way of getting started is through automated machine learning, which is really a capability that's based on years of Microsoft research innovation that's happening now baked into the product. Now, to do that, let me new or automate the ML run. And you'll see that for this demo, we've already created several data sets. And in this case, I'm going to select the retail training data. And this is essentially data that captures a lot of retail transactions. And then when I click next, it's going to show you, where do you want to run or train your machine learning model on, right? And of course, here I could say I want to select an existing experiment, or I could create a new experiment. Now, for the purpose of this demo, I'm just going to use selecting an experiment that I've created earlier. And in order to do machine learning, specifically supervised learning, you will often have to specify what do you want to predict. In this case, we refer to it as the target column. And here, because we're trying to do it as a regression task, we're going to say, let us predict the quantity. And once all this is all selected, of course, it's going to ask you to say, well, you're going to do automated machine learning. Where do I want to run the training code? And here I'm going to select a retail compute cluster that I've created earlier. And then I go on to do next. Now, this is the point in time when they say, hey, you're going to do machine learning. You have some data or some retail data that's sitting in storage. What do you want to do with it? What kind of model do you want to do with it? And in this case, because we're trying to predict a numerical value, which is quantity, in here, you want to be able to predict continuous numeric value. I'm going to select regression. Now, once I'm done and I click finish, what is happening in the background is we're creating an automated machine learning run, right? And underneath the hood, it's going to enumerate through a whole set of machine learning algorithms, if you will, and try to find the best one or the best trained model that will enable you to predict the quantity effectively. Now, as this is running, let me just show you some of the prior run that I've done, right? And of course, through this environment, you could go to home, you could create a notebook, if you will, you could leverage the designer, if you will. But let me look at one of the runs that I have completed earlier. And if I click on it, of course, it'll show you some of the metrics. And it will also show you if you're doing a deep learning task that's trying to understand images, the images that are used, and so on and so forth. And so you can get very detailed information about each run. And so once automated machine learning has found the right model, the best model for you, you're ready to deploy this into Azure Data Factory. Or in a while, Nellie is going to show you how can you leverage all these machine learning models within Synapse Analytics. Now, so with that, what I'm going to do now is go hand it over to Nellie, who's going to share with you more exciting stuff that's coming.
Thank you, Hyong. Thank you so much for that overview. All right. All right, everyone. So Hyong just talked to you about how you can leverage, for example, Azure Data Factory to build pipelines, or how you can build machine learning models easily in Azure ML. And those were some of the capabilities that are existing in Azure. Now let me talk to you about Azure Synapse Analytics and how Azure Synapse basically brings a lot of what Hyong was showing you earlier in both Data Factory and in Azure ML together in one platform. But before we do that, I really want to talk to you about why. Why did we build something like Azure Synapse Analytics, which is an analytics platform? Well, to tell you the background, it really started with a lot of research that the team did. We spoke to up to 1,000 customers just to understand what are some of the challenges that organizations face when it comes to AI analytics and managing data, right? And everywhere we went, we kept hearing about challenges of having silos of data. And when it comes to silos, it basically means that the pain points that were described to us were really about no easy way of bringing the data together from various different sources. But not only that, it's not only about data being in various different, databases and different types of systems. It's also about the metadata that exists in all of these different systems, right? It's the incoherent security models. It's the inconsistent developer experiences, that there's not really truly one platform where the users could do most of their analytics. So basically, what exists in many organizations out there are completely separate worlds of data. Like you see here on this slide, that on one side you have the world of big data, basically, where oftentimes the data sits in a data lake. You may use compute engines like, for example, Spark, that are scalable, that can process this huge amounts of data, but also have powers for experimentation, for exploration, and data science, most importantly. A lot of machine learning workloads are running in these environments. If you're on premises, you may have, Cloudera clusters and, kind of the Hadoop ecosystem that you're using. And if you're in the cloud, there are various different solutions for you to leverage kind of this big data infrastructure. On the other side, you have the typical business analytics workloads, which is based on relational data sitting typically in data warehouses that have a very proven kind of security model, a lot of rules and regulations for compliance, and their performance is also extremely important to deal with data at this scale, but of a different nature. And these systems often feed into the world of, let's say, business analytics, for example, into Power BI reports, and to report into for business decisions. Now, obviously, having these silos, as I mentioned, has a lot of different challenges. So our thinking with Azure Synapse was, how can we introduce a platform that can marry these two worlds, that can basically break these silos and create one place where you can analyze and manage and monitor these workloads. Now, with that brings us to Azure Synapse Analytics, where we basically said that let's bridge these silos. Let's create this unified experience on top of these systems, underlying systems. And going further with what Synapse is doing, it's really not only about, we'd say, as I mentioned, it's really not only about the data. It's very much also about, for example, if you're in Azure, you can probably construct, Spark workloads that integrate with relational workloads in a data warehouse or in databases. But for doing all of these things, some of the challenges that you have to go through are, for example, related to network security, access control. Even if you would stitch these things together on your own, you would still have to spend substantial amount of time to really make sure that the network security that you need is in place so that these services can communicate, for example, across VNets. And how do you do your monitoring? How do you manage your CI/CD pipelines? So all of these extra things are things that you would have to think about as you're kind of stitching that together. But with Azure Synapse Analytics, our ambition and our goal is really to simplify this for our customers. We see that a lot of customers do these integrations manually in Azure, for example, and we've seen the pain points around those things, to continuously having to manage the network security boundaries and all of these things. And it's a huge cost for our customers to be able to do all of these things. And with Azure Synapse, we're basically aiming to making that simple in almost like a one-click deployment of saying you deploy Synapse Workspace. And with that Synapse Workspace, you get a lot of the things already stitched together out of the box. Now, let me describe to you and take a look at what Azure Synapse is, besides something that brings together these two siloed data worlds. What you see here is a high-level, kind of simplified architectural overview of Azure Synapse. And we can start here by saying that you see this box here that kind of goes, the rectangle that goes around the different components inside. And think about that as this, within one security boundary, a place where you can get various different Azure capabilities that can seamlessly integrate with each other within the same notion of a workspace. We can start with at the bottom here with the storage that you see here, these gray boxes. Obviously, when you're dealing with data, you need somewhere to store your data. And I'll show you this in a bit as well. But when you create an Azure Synapse workspace, which is free to create, you will basically create this bag that has these different capabilities inside it. And as you create your workspace, you have the option to link storage to be associated with this workspace. And what that means is that if you're already using Azure Data Lake Storage, which a lot of our customers are doing in Azure, you simply bring that data lake into your Synapse workspace as a default storage to work with. If you have additional data lakes that you want to link to, you can do that as well. You can link other additional storages. And this is a way for us to say that whatever data lake storage that you have today in ADLS, you can bring that in to work with Azure Synapse Analytics as your analytics platform. And obviously, as kind of you have this data lake, you have data that's going to land in your data lake, right? And to your left here, you see that the data can come from various sources on premises, from different cloud sources. There could be different types of data landing in your data lake. And Azure Synapse, thanks to its built-in native integration with Azure Data Factory, which was what Hyong was talking to you about a while ago. And thanks to that, Azure Synapse can bring you a lot of the different abilities to connect to the different sources. If you remember the 90+ connectors that Hyong was talking about, bringing that capability in Synapse so that you can leverage those type of connectors natively inside of Synapse to connect to your different sources to get your data to where you need it to be, for example, in the data lake, for example. There's also, if you look at Azure Synapse Link, which is the other gray box there, we also have native capabilities within the Synapse workspace when it comes to virtualizing data, basically reading the data as at its source. And we have, for example, Azure Synapse Link, which is a very high performant way to virtualize data over Cosmos DB's analytical store. So these are some of the capabilities we're talking about data in itself in the Synapse workspace and what type of data that you can work with in Synapse. Now, moving to the analytics runtimes that you see here in the middle, you'll see that you see SQL on one side and then you see Spark. And the fact is that Synapse actually offers both. We realized that if you remember the picture with the two different siloed worlds, I was talking about how Synapse is bringing them together. Synapse includes SQL compute engines in the form of our SQL pools, which can be provisioned SQL pools, which is basically the SQL data warehouse in Azure, that you may know it as, and the serverless SQL pools that are an on-demand type of SQL engine for more ad hoc querying. Now, what this means is that if you already are using, for example, Azure SQL Data Warehouse, or if you want to use that, that's basically just a part of Synapse. It's one of the analytics runtimes in Synapse. But let's say you're not using a data warehouse, but you have a lot of data in your data lake that you want to explore and understand and query using SQL, because that is the language that your teams prefer to use. You can then freely use choose to use Azure, the on-demand SQL pools, where you basically don't have to provision any resources. You simply pay as you query for the amount of data that you're querying. So it's a very simple way to, out of the box, in a workspace, basically just have your data in the data lake, and I'll show you that in a bit, and start querying that data directly using SQL Serverless as one of the analytics runtimes. On the other side, we have Spark, which is, really made for scalable data processing. So if you have large amounts of data and you need to do data preparation, data wrangling, Spark is really the tool to be able to manage that. And as I mentioned, these compute engines are part of the Synapse workspace. Everything is within the same security boundary. You don't have to worry about setting up different VNets that can communicate with each other. All of that has been taken care of. But on top of that as well, we realize that it's not only about security, it's also about the experiences to manage these workloads. It's the experiences to monitor the different jobs that are running, for example. It's experiences to manage everything, and obviously to integrate these things. And the integration piece here really ties to what Hyong was talking about earlier with the capabilities that we're bringing in from Azure Data Factory. We can build data pipelines, and we can do all of these things with the data that's flowing through Synapse. And Azure Synapse Studio is then the experience that you will see that I'll also show you, which is really the place where you do all of these things. And before I forget, I also want to emphasize one thing, which is that, we have these SQL analytics runtimes, we have the Spark compute engine that we're using, but there's also this bridging between these different runtimes when it comes to our metadata story. Because we realize that whether you're working on the SQL side, for example, you prefer to use T-SQL to query your data, or whether you prefer to use PySpark to query your data, it really is about, the data and the data sets may very well be the same in many cases. They're sitting in your data lake. So some of the things that we're doing, just to give you some examples, is that we have a shared metadata model for these two different analytics runtimes. This means that if I'm working on a Spark table that's working on Parquet files over my data lake, that Spark table is also available to me as an external table on the SQL side, so that I can query that table seamlessly from SQL. So these are some of the things, examples of things that we have done to break the silos, as I mentioned. And furthermore, there's about the integration between what's in the Synapse workspace with other very valuable Azure services that we want to integrate with. And we have done key decisions on being very intentional with, for example, specific integrations which we feel are key to the scenarios that we want to enable within Azure Synapse Analytics. And some of them you see here to the right. For example, you see here that we have an integration with Power BI because we know that a lot of our customers are using Power BI as a tool for reporting on top of data that sits in Synapse. There's also integration with Azure Machine Learning that I'll show you a little later, which allows you to bring in models from Azure Machine Learning and basically bring in those ML capabilities together with the existing ML capabilities in Synapse. And I'll also cover that in a bit. Now, on the theme of the integrations, let me talk to you about different types of integrations, because I think this is important for you to know that there are different levels of integrations. If you think about what systems, what services that Synapse integrates with. Now, looking at, for example, the linked services, this is really a lot of things that we uncovered around the 90 plus connectors and the power of Azure Data Factory to connect to these sources. And thanks to the native integration with Azure Data Factory and seamless integration, I have to say, and we'll show you that in a bit, it basically shows that if you're working in a Synapse workspace, you have access to those 90 plus connectors, and you can connect to those 90 plus sources to get your data into the Synapse workspace. Now, there's another level of integration, though, where we've chosen to do deeper integrations that enable a more end-to-end scenario between Synapse and specific services. And some of them you see here, for example, Azure Data Lake Storage Gen 2 is one of those key integrations where working with your data in the storage within the Synapse workspace is really very seamless. To the user, it's really no different than working with kind of data that's managed within Synapse itself physically. Similarly, Azure Machine Learning, we're doing a lot of work there to introduce seamless experiences between Synapse and Azure ML, where we bring pieces of Azure ML into Synapse to really help the Synapse users to be able to leverage machine learning to its fullest. And then, of course, as I mentioned, Power BI. Azure Synapse Link, I already mentioned that, but that's yet another level of integration where we're integrated in such a way so that we can virtualize data, read data at the source in real time over the Cosmos DB analytical store. And I'll mention an example of how you can use that data, for example, in your for ML workloads. Now, let's take a look at machine learning capabilities, because this talk is supposed to be about machine learning, right? And what are the capabilities for machine learning within the Synapse workspace? I'll mention some of them, and we'll kind of deep dive in some of them in a bit. If you look at on the SQL side, on the analytics runtimes, in our data warehouse, for example, we have introduced a native predict function in T-SQL that allows you to run batch scoring in the context of SQL, within the security boundaries of SQL, right where the data lives. On the other side, on the Spark side, we have introduced Apache Spark, right? We have Apache Spark, which basically means that we have a very powerful engine to run batch scoring and also do model training on Spark. So at a high level, these are some of the capabilities for machine learning. And as we kind of move forward, I'll talk a little bit more about each of those. All right. Let's start with the native predict function that I just mentioned. And native predict is really, a feature that was introduced in SQL Server So no matter which SQL engine that you work with on-prem or in Azure, this capability actually exists. It's a T-SQL-based predict function that allows you to bring in Onyx models today. And Onyx is a format for models that makes the model more portable. So you can basically convert models of, whether they're scikit-learn, whether they're PyTorch, different flavors of models you can bring in and convert those into the Onyx format, which means that you can then use those models for scoring in a very simple way within the context of SQL. And in this case, the SQL data warehouse, which means that this can run at scale on the different nodes of the data warehouse, simply by calling a function called predict, providing a model. And this model is also serialized in the database in the form of a hex string, so that the model is actually saved in a table, in a database table, as you store any other type of data. And you basically point predict to your model and to your a table where you have your data, and you'll get a result set where the predict function is going to enrich your data. And I'm going to show this in a demo in a bit, exactly how this works, using one of our newer experiences in our studio in Synapse, to show you how you can actually very easily, through a wizard, operationalize your models from Azure Machine Learning within our SQL pools inside of Synapse. So this was one of the kind of orange boxes that you saw on the previous slide. Now, let's talk about Spark. If you're familiar with Spark, I'm sure that you already know the capabilities that you in Spark to perform machine learning tasks. One of the simplest ways to apply machine learning on Spark is really to leverage the Spark ML algorithms. And to give you an idea of what type of algorithms that are supported on Spark ML, which is Spark ML Lib, which is a library that you can use on Spark, which basically uses these algorithms to train models in leveraging the full distributed power of Spark. So with these, you can, for example, do classifications and regressions. If you remember, Hyong was showing you a demo of AutoML in Azure ML, where he was using regression to be able to estimate a value, a numeric value. AutoML provides a more visual way to do that through a wizard. All of these algorithms are basically similar algorithms that the one that, for example, Hyong was using for his model training. It's just that users can use these from Spark, for example, from PySpark code. You can invoke these different algorithms to train your models. And then later doing, for example, batch scoring to get your predictions out of them. So Spark actually has that capability built in thanks to the Spark ML library. And there are also other types of libraries that do run in a distributed fashion on Spark. But this one is probably the most famous one. So I really wanted to cover this just to give you an idea of what is possible to do on Spark pools in Synapse. Now, in addition to Spark ML that I mentioned, in Synapse, out of the box, we also include the MMLS, Microsoft Machine Learning for Apache Spark library. And this is a Microsoft library. It is an open source project and a Microsoft library that basically expands what beyond what you can do with, for example, Spark ML. It basically brings in the capabilities and algorithms like GBM, and adds many deep learning and data science tools to the Spark ecosystem. So this is a very interesting library to leverage, and it's very popular. And some of the things that we're doing is that we're actually also leveraging this library to be able to reach out to cognitive services. And if you're familiar with cognitive services, you may know that it is a service in Azure that provides cognitive models, for example. These are pre-trained models that you can use, for example, for sentiment analysis or for anomaly detection and these type of things. So these are pre-built models that can be leveraged. And on Spark, you can actually leverage them directly from your code using this MMLS for Spark library. So it's definitely a library to be aware of if you want to leverage and do ML on Spark, and specifically Spark Pools and Synapse, since it's included out of the box. Now, when it comes to our Spark Pools and the work that we're doing, I mentioned that we're using Apache Spark as the foundation, but there's also a lot of things that we're doing to make sure that all the workflows that are running on Synapse Spark Pools are running on a performant Spark engine, that we have the capabilities that our customers are asking for, and that we're bringing innovation from Microsoft and using that in our Spark Pools to make it a lot more easier for our customers to get the value that they want for their workloads. And if we start here at the top of this pyramid that you're seeing, we want to show basically and list some of the things that we're doing because our customers are giving us feedback that's useful. For example, metadata integration with Synapse SQL, as I mentioned. If I'm working and have a table definition over data in my data lake, that table definition should be the same, really, whether I'm using Spark or SQL. And that's something that Synapse uniquely provides, is that if you create a Spark table under Spark Pool and you later want to continue to work on that data from SQL, you can do so because they share the same metadata. MS Spark Utils is a utility that we've added based on customer feedback, just to be able to make it a lot easier for our customers to do certain tasks, for example, on our Spark pools, very common tasks. And we've introduced Scala experience in IntelliJ, for example, just to name something based on feedback from customers. We've improved our notebook user experience based on feedback from customers. So listening to customers is really, really the most important thing for us, that we listen and we can provide features that our users are asking for. Now, if we go to innovation, I would say that besides listening to customers, we're also bringing some of the innovation that comes from our research teams into our Synapse Spark pools. And some of this is related to caching and smarter and more efficient caching, for example, for better performance. We introduced .NET for Apache Spark. We have, as I mentioned, done a lot of enhancements on the performance side to make sure that the Spark that you're using in Synapse is performant compared to other Spark offerings out there on the market. And some of the examples of some of the projects, for example, Project Hummingbird, and I may have time to show you that in a bit, what that is, but it's really about model optimization. And it's a project that comes from our team and that we've contributed to and made it open source. And then, of course, the foundation, last but not least at the bottom here, the foundation of saying that, we're building on Apache Spark. We currently have support for Spark 2.4. We're working on supporting Spark 3.0. And we have the shared Spark code base with HD Insight that you may know, service in Azure, which means that we're really leveraging the power of Microsoft and all the knowledge that exists in that code base and in those teams to make sure that all the learnings that we get from our Azure services when it comes to Spark, that we incorporate those learnings and make our Spark offering better. Now, let me, before I jump into a demo, we're talking about these different machine learning capabilities, right? And before I jump into a demo and show you a little bit of an overview of, what is Synapse, what does it look like, what is the workspace, I also want to walk you through a scenario that I want to demo for you. And it always helps to kind of have seen the scenario and an overview of it before we jump into it and before we kind of start clicking around in the Synapse workspace. Now, the scenario that I'm going to talk to you about is really about going to focus on the integration with Azure Machine Learning. And some of the things that we're doing together with, by leveraging, for example, models in Azure Machine Learning and the integration that we're working on with Azure Machine Learning. And the scenario here is that, we know that there are different types of roles and different in organizations, right? There are people who are more, focused on machine learning tasks, and we call them, in this case, machine learning professionals. Machine learning professionals are used to developing machine learning models, for example. And those machine learning models can be developed in many different places, really anywhere. But for the sake of this scenario, you can imagine that the model is either trained, for example, in the Synapse workspace itself on Spark, or it's trained in Azure Machine Learning directly. And obviously, you typically have the data scientist or the ML professional in this case has their notebooks, they're developing the model, training the model, same thing. And in the end, what's produced from that is a model. And in this case, this ML professional is training a model that's producing that's an Onyx model. So it's being converted to Onyx in this case. As this person is training the model, the person is also adding something to the model that we could call a signature. And this signature basically means that, as the person who's training the model, I know what the inputs are that this model is expecting, and I know what the outputs are that the model is expecting. And I'm probably the best person to add that little sticky note on the model, add this signature to the model to say, hey, this model expects these things, these columns of these data types, and this model is going to output this column of this data type, for example. And this is the model signature. So in this scenario, what's going to happen is that the ML professional is adding the signature to the model before the model is logged in a model registry. And just to give you some context of what is a model registry, if you know Azure Machine Learning, you already know what a model registry is, which is really, if you're in an enterprise and you have all these different models being developed by these different data scientists, for example, in various teams, you ideally want a place where you can track the different models, you can track their performance, you can track where they have been deployed. And this is really all about having the capability to do ML in an enterprise. So this is what an Azure Model Registry is. And this particular model in this scenario is going to be registered in the Azure Machine Learning Model Registry. Now, there are other people in an organization, right? There could be other teams, and in this case, this happens to be a data engineer, someone who is responsible to operationalize these models for data enrichment in the context of SQL pools inside of Synapse. This person doesn't really have to know anything about how to train a model, but this person will have the capabilities in Synapse to be able to connect to an Azure Machine Learning Model Registry to select a model, and in communication with the data scientist, perhaps selecting the model that should be deployed into Synapse. Now, as part of selecting that model and getting that model, that same signature that you just saw, this little yellow sticky note, is following the model so that as a data professional in Synapse, for example, this person doesn't have to know what are the inputs, how is this model trained, how am I going to map the different columns from my table into the model. A lot of that information is part of that signature that the machine learning professional provided. And thanks to that, the data professional can now operationalize and deploy this model into the Synapse SQL pool to run the T-SQL predict statement that I covered a while ago. So this is the scenario that I want to show you. So let's jump into a demo and take a look at, how all of this works in Synapse and, what Synapse really looks like. And for that, let me share my screen. All right. So what you see here is an Azure Synapse Analytics workspace. And if you go into the portal, for example, just to show you how you can create one, and you search for Azure Synapse Analytics, you see here that there's the concept of Azure Synapse Analytics workspaces. Now, this is the resource that you would create to work with Azure Synapse. And I just wanted to show you that briefly to know how I kind of got to this place. So here you see that I have a Synapse workspace. This is my home page in my Synapse workspace. I have what you see here, first and foremost, is something that you may recognize as the modern data warehouse pattern, where you ingest, explore, analyze, and visualize. And these are all the things that you can do in Synapse. Synapse also has a knowledge center that contains a lot of documentation, a lot of getting started sample code, and things like that that you can use to get started within Synapse. Now, what you see here to the left is a series of different hubs. I'm in the home right now. What you see here, in addition to that, is my data hub. I have my develop hub. I have my integrate hub, my monitoring hub, and I have my management hub. Now, let me give you a brief overview of all of this before we jump into the scenario that I was just describing. Now, let's go to the data hub and show you a little bit what I can do here. So, as I mentioned, in Synapse, there's the concept of the data that's within my workspace. For example, I have my different managed tables here that you see. These are kind of data warehouse tables that I have. In the same way, you see here that I have different Spark tables. I have even SQL serverless databases. And by serverless, I basically mean that that SQL that you can use without having to provision a resource necessarily in your workspace. All right. So let's also take a look at the other types of data that I can have. There's this workspace data and there's the linked data. In my workspace, just pretty seamlessly, I can get access to integrated data that I have. This is data that doesn't necessarily physically sit inside of Synapse, inside, for example, SQL Data Warehouse or anywhere else, but my data lake is basically a native storage to my workspace. And you see here that I have a primary storage here that is actually my ADLS Gen 2 account. And I can explore the data in my data lake just as seamlessly as if the data was in a table, really, in my workspace. You see here that I can see all my files. I can see my directories. For example, let me go into this folder here, and you see here that I have, for example, a CSV file, a Parquet file. Let me right-click on this file and start exploring this immediately. And let's say I have a Parquet file here, but I want to explore this with a SQL script. Now, what you see here is that there's a built-in SQL here, right? And this basically means that this is the serverless SQL that I can use to directly start exploring the data that I have in my data lake. There's really no other barrier. I don't have to move my data into some place first and to make it accessible for a SQL engine to read it. I can directly, over my data in my data lake, start exploring my data, start analyzing my data. I get built-in visualizations that I can leverage, for example. And it's really not harder than that. And we've really focused on making this as friction-free as possible and reduce the barriers for you to get started in exploring your data within Synapse. Now, if I go back to my storage here, you can see here that I have a CSV file, for example. And similarly, if I choose to say that I want to load this in a data frame and I want to use PySpark to explore this, similarly, I can attach this notebook to different Spark pools that I have created in my workspace. And each of the Spark pools is basically a definition of a cluster, which means that when I start up my session, I'm going to get a Spark cluster following that definition, the size, for example, and the scale that I've chosen when I provision that cluster. And then I can start exploring my data, for example, in PySpark. And this is really how easy it is to get started in exploring your data. You basically just need your data lake, and you create your Synapse workspace, and you're off to go. And this is the Data Hub. As you see here as well, I happen to have a Synapse link to a Cosmos DB analytical store. And here, what you see here is actually the Cosmos DB tables that I have, and the link that I have that I've used to connect directly to that analytical store. And there are also various different other linked data sources. You see Azure Data Explorer here, Azure Blob Storage, and as you see here, we try to make the experiences very native, so that it doesn't really feel like you're really talking to a separate service or something outside of the Synapse workspace. So that was the Data Hub. Now, if we move into the Develop Hub, you see here that there are SQL scripts that I can work with. There are notebooks that I can work with. There are also data flows that I can work with, which comes from Azure Data Factory, if you're and some of the things that Wei Young was talking about earlier. Excuse me, just a sip of water here. All right. Now, these different hubs basically allow you to do different things. And there is access control for you to be able to control which users that can access, what capabilities. And I'm going to skip this one for now. I'll have Ryong kind of come back to this, but this is really about the different pipelines and what Ryong was showing you earlier around the capabilities of Data Factory that are really built in this experience, so that you can leverage all of that goodness from within your Synapse workspace and not having to kind of treat it as a separate service, etc. It's all built in. And then obviously monitoring, important if you're running different types of jobs, if you have Spark jobs, for example, if you have SQL jobs, your pipeline runs, to be able to really monitor your different types of workloads. For example, you see here my different workloads. And here you can also see how you can create different types of, for example, linked services or provision resources. So for example, as I mentioned, the Spark pools, this is how you would create a Spark pool, for example. And it's really easy, given that you have permissions, obviously, to create these type of resources directly in your workspace. One thing I wanted to show you here briefly, because it's related to the scenario that we just saw, is really the linked services, which is the linked services that Azure Data Factory provides, which is all kind of built-in capabilities inside of Synapse, where I can, for example, link to my Azure Machine Learning workspace that you see here, for example, to be able to work with Azure ML. And that is actually something that I'm going to show you in a bit. So I need this linked service to my Azure Machine Learning workspace to be able to run through the scenario that we're going to go through right now. So let's think back of the scenario that I was showing you. I mentioned that an ML machine learning professional is training a model, and that's exactly what we're going to do. We're going to train a model, or we have trained a model in this case, that's actually reading data over Azure Cosmos DB's analytical store. So it's actually using the Synapse link in this notebook. So as the ML professional has easily been able to pull in data, and that's what you see here, pull in data from Synapse link, using Synapse link directly into my notebook, and start working with those tables and joining those tables using PySpark. Now, after my data is joined and I've basically done some featureizations on it, I've removed some columns, for example, and cleaned the data a little bit, and prepared my training training set and my testing test set, for example. I can train a model. In this case, we've trained a random forest regressor model. So this is still regression. It's still going to predict a specific value. And what we want to predict in this case is that we have data from a retail store, and we want to predict the quantity of sales. So it's basically a sales forecast to be able to predict how many items we're going to sell for each kind of item type. And once we've trained this model, as you see here, we're going to convert this model into the ONNX format. And this is the format that I was mentioning to you earlier, that it's a more portable format and the format that our SQL pools understand, because what we want to do with this model is that we want to register this model in the Azure ML model registry. And then once we've done that, we want to pick that model and deploy it into our SQL pool for prediction using one of our new experiences. Now, if you take a look at this model, you also see that it's kind of a tree-based model, and this is something that I just wanted to show you because I wanted to tie this back to some of the innovations that we are bringing into our Spark pools, because what our team has been working on is something that we call Project Hummingbird. And Hummingbird is really about model optimization. I really wanted to mention this just to show you a glimpse of some of the innovation that we're bringing into Synapse Spark, which really is about, I had an ONNX model. It's a tree-based model that you can see here. It's a representation of the model. Now, by using Hummingbird, it basically takes the traditional model that you just saw, the traditional ONNX model in this case, and converts it into a deep neural network. And what this does, is that it can actually prove to speed up your predictions just because of this change into a DNN form. As it's mentioned here, you can get up to 5 times speed ups on CPU, but significantly larger speed ups on GPUs. And for this particular model, we've actually used Hummingbird to convert this model and optimize it. And you can actually see for this particular model what the optimization led to. This is the original SQL to ONNX kind of scikit-learn model that you saw. You see that it takes around 4 seconds to run the inferencing, the predictions. And then you can look at how much faster it is on CPU and how much even faster it runs on GPUs. Now, this is really just to show you that thanks to innovations like Hummingbird, you could actually get these type of speed ups essentially for free, just because of some of the innovation that we're bringing in. And this is also an open source project, so Hummingbird is something that you can leverage even if you're outside of Synapse. So we really want to kind of contribute this to the community out there to kind of to speed up inferencing and making these models more optimized. And you can also see here that the construct of the model, the shape of the model actually changed. It became a deep neural network. So this image was just to show you that. All right, so let's move on. We have our model. We talked about performance for a bit. Let's go back to the scenario. We have an ONNX model. What do we want to do now? We have the ONNX model. We want to register and log that model in the model registry, because that is how we can track models. That is how an enterprise can truly work with thousands of models that different data scientists and ML professionals are producing. And for doing that, we're going to use MLflow. And I also wanted to show you something here, which is some of the built-in integrations in our notebook to say that I can connect to my Azure ML workspace and I don't have to pass any credentials. We're doing Azure Active Directory pass-through in Synapse notebooks directly to Azure Machine Learning as sort of a magic integration that we've added in our notebook, so that you don't have to worry about ever adding credentials in your code to be able to connect to an Azure ML workspace. And then we're leveraging MLflow to log this model, but also log the little yellow sticky note, if you remember, the signature of the model in the Azure ML workspace. Now, if we go and take a look at the model in the Azure ML workspace, and let me show you this particular model. Let's take a look at this one, for example. If I go into the workspace and I look at the model, I just wanted to show you this because it really will show you what that little yellow sticky note was. And this is really what it was. It's basically, as the person who trained the model, we've captured what are the inputs and what's the data type for each input that this model is expecting. Now, let me show you why that is important and why that is so important in the collaboration between the machine learning experts and the data experts. Now, as a data professional in Synapse, I have a different hat on right now. I want to operationalize the model that we just saw, and I want to do so in our SQL pool. So what I can do here is that I can go to one of my tables in my data warehouse, and I can select machine learning and enrich with existing model. What this does now is that it's leveraging the linked service that I showed you a while ago in one of these hubs to the left. And it's leveraging that linked service to connect to my Azure Machine Learning workspace, where I can select, and these are the same models that you could see previously, right? I can select a model and I can choose to deploy that model. And what's happening now is that it's picking up that signature for me, and it's doing this mapping automatically for me, so that as a data professional who didn't really train this model and doesn't really know what this model is or what it expects, I don't have to do a whole lot to be able to operationalize this. In this case, I actually don't have to do anything because the signature got everything right. So all I need to do is basically press continue. Now, next, I'm going to have to define a name of a stored procedure where my predict call to my predict function is going to be wrapped. So basically, this is stored procedure that's going to wrap the predict call, and this is really for me to be able to take the stored procedure that has the code, and I can call that stored procedure whenever I want, and it may make it easier for me to operationalize. So let me say that we want to run a test here, and we want to do a test for scoring, and I'll call this test scoring Nellie. And what's going to happen now is that the model that you saw in the Azure ML model registry, it's going to take that model and it's going to deploy that model into our SQL pools. So it's basically downloading the model, it's converting it to that hex string, it's pushing it into a table, and it's generating code for me, because as a SQL professional, I want to see the code that it's generating so that I can choose to look at it and see, is this okay enough for me to run? In this case, I trust this code and I want to create the stored procedure. I want to make the call to predict that you just saw here. So this was the call that we just made. And we pushed in the model that it's selecting from a table here and the data set that we just had. And what it gave me was the result set with the enriched column of quantity, which was the predicted function. Now I can use this, I can create a view on top of this, I can push this into my Power BI dashboards, and I can have the BI analysts who are working with this data to get this piece of information as kind of an enriched column to the data set. So this was just one example of a scenario that you can work with where you can basically collaborate and use Azure Machine Learning and facilitate collaboration between professionals who build models and professionals who work on the data and deploy the models. All right, and with that, let me hand over to Hyong to tell you a little bit about how you can leverage Azure Data Factory as a continuation of this scenario.
Hey, thank you, Nellie. Now, so one of the things that we talked about is that when we started off this presentation, right, was Azure Data Factory. We showed you what it is. But at the same time, we also showed you the power of Azure machine learning. And of course, Nellie brought it together and showing you how you could bring all of this together and being able to leverage all these different powerful capabilities within Synapse Analytics. Now, early on, Nellie went on to show you how you could then take some of these machine learning models that's been built in Azure Machine Learning and be able to use this and enrich the data, right, that's sitting in an Azure SQL pool. Now, but many a times when you're trying to do batch scoring, it's not just about scoring against the data that's sitting in some table, right? Many a times you might want to be able to transform them. You might want to include other kinds of activities that needs to happen before, and these activities could be, doing data preparation, it could be doing data transformation, and so on and so forth. And so earlier when you saw Nellie generate the SQL scoring script, if you will, you'll see that statement that says predict. That's leveraging the model that has been already brought back from Azure Machine Learning into Azure Synapse, right? And you're doing scoring. Now I'm going to show you next how you can leverage a lot of the skills that you might already have learned when you started using Azure Data Factory in the Synapse workspace. Now we're going to use the same workspace, but what we're going to do now is we're going to click integrate. And how do you go about leveraging that in a pipeline, right? And so the first thing I'm going to show you is really the SQL pool stop procedure. Now, where do you find it? You go to Synapse and you'll see a SQL pool stop procedure. Now, remember, earlier on, Nellie created a stop procedure, right, that encodes that logic, including that predict statement. And so essentially what this stop procedure is trying to do is if you click on settings, it is invoking the task scoring stop procedure, right, that Nellie has been using earlier in the predict pool. Now, what is inside this task scoring 1030 stop procedure, right? If you are to go back to the predict pool, you will see stop procedures. Now, of course, as this gets expanded, you'll see different kinds of stop procedure that's available here. And of course, we could scroll down. Right, you'll see the task scoring Nellie stop procedure that was created earlier. Now, if I were to click on this and show the script, if you will, this stop procedure that you see here can now be leveraged within this SQL pool stop procedure that's available within a Synapse pipeline. And so, of course, here I could then replace this with the task scoring Nellie. Now, and once this is done, of course, I could bring in other things that is within a Synapse pipeline. I could be copying data. I could connect this to say, well, if the copying or the data movement is successful, invoke this stop procedure. Now, after this has done and completed batch scoring, I could say, well, maybe I want to be able to generate and leverage a new data flow to continue working with the data, right? That is available in the SQL pool. And so if we go back to the pipeline, we can get all this connected together. And what we've just done is really, really powerful, right? Not only have you invoked or performed batch scoring using a machine learning model that was trained in Azure Machine Learning, right? We've brought it all together in the Synapse workspace. But more importantly, now you can get all these other different pieces that's needed in order to make sure that your entire machine learning pipeline is successful, all in one place within the Synapse workspace. Now, of course, you could continue doing many, many other things as well, right? You could say, well, maybe I want to include this in a for each loop, right? Or I might want to say, well, I might want to specify an if condition, and if it's true, do something about it. And so what you see here is a lot of these activities that you see in this Synapse workspace is exactly the same set of skill set, right, that you have learned and grown to love earlier in Azure Data Factory. Now this is all brought into the Synapse workspace in order to enable you to have one single tool, right, to do all of this really, really efficiently. Now, the other thing I wanted to show you is, well, what about, recall that earlier on it was a SQL statement with a predict clause. What if you want to invoke that as part of copy? You might want to say, well, invoke batch scoring, get the predicted results, but then you want to copy and insert this into some other data targets, if you will. Now, so the other thing I wanted to show you is I could then leverage a copy statement. But inside this copy data activity, if you will, if I go to the source, you will see that here I could leverage a stored procedure, or I could leverage a query. Now, the same query that happens within the stored procedure, you can copy the code here, and now you get the ability to be able to use the copy, right, where the source is leveraging machine learning capabilities to do prediction, but you do not want this to land somewhere. You want to be able to then copy this to some specific target so that you can continue the rest of the interaction. Now, the last piece I wanted to show you before we close off this demo is, recall when we were showing you the Azure Machine Learning demo, we created a machine learning pipeline in Azure Machine Learning. Now, you could also invoke machine learning models directly within Synapse Workspace as well. And so here, you'll see that I have created a predict retail AML pipeline. And what you'll see here is if I go to settings, I've connected this into Azure Machine Learning. But more importantly, I have selected a pipeline, and this drop-down will show you the different kinds of machine learning pipelines that's in Azure Machine Learning. And in this case, I'm saying I want to do retail quantity prediction. It will have populated the pipeline identifier, and it will have asked you to specify an experiment name, right? And so once all this is done, I can kick off this pipeline. And when I click OK, what is happening within the Synapse workspace is we're getting this pipeline to run, but it is actually invoking the machine learning pipeline that's sitting in Azure Machine Learning. And so right now, what I've shown you is 3 really powerful ways of leveraging machine learning capabilities in the Synapse workspace, right? Building on what Nellie had showed you earlier. Now, so with that, let me hand it back to Nellie to close off the talk.
Thank you. Thanks, Hyong. Let me just quickly share my screen so that you can all see some of the resources that we wanted to share to basically leave you with some links, some resources so that you can learn more about this, because what we talked about today was really about some of the key powerful capabilities in Azure Data Factory, in Azure Machine Learning, and how they can come together in Azure Synapse Analytics to really help you work with your analytics solutions and build those analytics solutions. This list, please save it. Please go to these links. They will provide you with material and samples and knowledge about how to get started and how to better leverage Azure Synapse and Azure Data Factory, for example. And we hope that you found this useful. We hope that some of the things that we talked about today sparked an interest in learning more about these topics, and we hope that the power of all these different capabilities within one place, under one umbrella, kind of shows you all the possibilities that are possible within Synapse, thanks to Azure Data Factory, thanks to Azure ML and the built-in Synapse capabilities. Yeah, and with that, I think I think we're ready for basically we're ready to end the talk.